Good morning. Today we can discuss some problems in rotation under a constant moment. Then before that we can derive an analogy between linear acceleration and angular acceleration. Similarly, linear velocity and angular velocity. Here, this particular point is on a circumference of a curve, then a particle moving from A to B. Here radius of rotation is equal to small letter r. Then this displacement, angular displacement is equal to theta. That means this displacement is equal to s. Then v, velocity is equal to, linear velocity is equal to ds by dt. If theta is infinitely small, we can treat this as a straight line. Then v is equal to ds by dt. Is equal to d by dt of r theta. This curvature is equal to r theta. Then d by dt of r theta. Then that's equal to r. R is always a constant for rotational motion. Then r into d theta by dt. Then that d theta by dt is equal to omega. Then linear velocity is r omega. Linear velocity is equal to radius of curvature into angular velocity. Similarly, for acceleration A, dv by dt, that's equal to d by dt of r omega, Then once again, r is always a constant, r into d by dt of omega. Linear acceleration is equal to r into d by dt of omega, r into d omega by dt, that's equal to r into alpha. D omega by dt is equal to the rate of change of angular velocity, that's equal to angular acceleration. Then A is equal to r into alpha. Then linear velocity is equal to r into omega. Then linear acceleration is equal to r into alpha. Here v is equal to r into omega, and A is equal to r into alpha. Okay, then first problem in rotation under a constant moment. Here, a right circular drum of radius 0.3 meter. Here, radius of the drum is equal to 0.3 meter, and weight 150 mm. And the weight 150 Newton. Is free to rotate about its geometric axis as shown in figure. Wound around the circumference of the drum is a flexible cord carrying at its free end a weight 45 Newton. If the weight is released from rest, find the time t required for it to fall through the height of 3 meters. And here the vertical displacement of this object is equal to 3 meter. Find out the time required to reach this or travel this 3 meter, vertical distance of 3 meters. This is the question. Here this weight is initially at rest and freely falling. These two conditions are given. Then a solid right circular drum is in the form of a right circular disc, and it rotates about an axis which is perpendicular to the plane of this circle, plane of this area. Then the moment of inertia of this disc about an axis which is perpendicular to the plane of the circle or plane of the disc is equal to, already we discussed that matter in the previous class. Then that moment of inertia is equal to mr square by 2. That moment of inertia z is equal to mr square by 2. Then torque is equal to torque required to for the rotation of this disc. Torque is equal to P into R. Here P is this force. Then we cut this string here developing a tension in the chord P like this, and P into this R is equal to the torque is equal to P into R. Then already we discussed this torque as I alpha. I is equal to mass moment of inertia. Then this I alpha, T is equal to I alpha, that's equal to mr square by 2 into alpha is equal to a by r, linear acceleration divided by r, or linear acceleration is equal to alpha into r, then a by r, then this torque is equal to P into R is equal to m r square a by 2r, that's equal to from this equation P is equal to, we can cancel the one r here, and then ma by 2, then P is equal to P, this tension in this ring is equal to ma by 2. Then consider the vertical motion of the object, consider the vertical motion of this particular weight. Then we can apply D'Albert's principle here. F is equal to ma, or sigma F is equal to m into a, where sigma F means sum of total external forces acting on the body in the direction of the acceleration. That must be equal to that mass of the object into acceleration. Then here the acceleration is always downwards. A is the acceleration that is towards the downward direction. Then total external force means Q minus P. Q downward, then P upward. Q minus P is equal to here mass of the object is equal to Q by G into acceleration. This is the equation. Then applying D'Albert's principle, Q minus P is equal to Q by G into A. Then Q minus P is equal to ma by 2 is equal to Q by G into A. That means we can take Q by G by A here. Then Q minus Q by G into A is equal to ma by 2. Then Q into from this equation we can take Q out of bracket, then 1 minus A by G is equal to ma by 2. Then from this equation we can calculate Q. The value of Q is equal to 45 Newton. Then acceleration, we can find out this acceleration. Here mass of the object is equal to weight 150 Newton. That means mass is equal to 150 by G. We can easily calculate acceleration. A is equal to, acceleration is equal to 3.68 meter per second square. By substituting value of Q and G and M, we can easily calculate acceleration. Acceleration is equal to 3.68 meter per second square. Then this displacement H is equal to ut plus half at square. Then here initially this object is at rest, that means ut is equal to 0 plus half into a is equal to 3.68 and t square. We can find out this t by applying h is equal to 3 meter at t square. Then that t is equal to 1.28 seconds. 1.28 seconds. This is the final answer of this particular problem. T is equal to 1.28 seconds, and this linear acceleration is equal to 3.68 meter per second square. Okay, next problem. The rotor and the shaft weighs 2500 Newton and the radius of gyration with respect to the axis of rotation is 250 mm. Calculate the acceleration of the falling weight 450 Newton if the shaft radius is 125 mm. Shaft radius is equal to 125 mm. Here again we can mark this tension like this. This P like this, P. Then once again torque is equal to torque. This rotating torque is equal to P into R. P into R. Then that same torque is equal to I into alpha. I into alpha. Then P into R is equal to I into alpha. I into alpha means I is equal to m k square. M k square where k is the radius of gyration into R. Alpha is equal to A by R. Alpha is equal to A by R. Then P is equal to mk square by R into A by R. A by R. That's equal to here mass of the objective. Mass of the object is equal to 2500 Newton. 2500 Newton divided by G. Divided by 9.81 into K square by R. K square. Radius of gyration already given in this question, 250 mm. That means 0.25 meter. Mk square by R. R is the radius of the rotating object. That radius is equal to shaft radius is equal to 150 mm given in the question. That means 0.125 into R means R square. 0.125 R square into A. Then here P is equal to 1019.37 A. Equation number 1. We can easily calculate that tension in the string. Then again we can apply that D-Albert's principle. D-Albert's principle here. D-Albert's principle. Then sum of total external forces. Total external forces is equal to W minus P. Sum of total external force, W moving downward with an acceleration A. Then sum of the total external forces. Force in the direction of acceleration must be taken as positive. Here W must be taken as positive and P must be negative. W minus P is equal to W by G into A. W by G into A. W by G into A. Then W is equal to P plus W by G into A. P plus W by G into A. That's equal to P. Here P already found out. 1019.37 A plus W by G. W is equal to 450 Newton divided by 9.81 into A. W by G into A, that's equal to W, that's equal to W. Then this one is equal to W is equal to 1065.24 A is equal to W. 24 is equal to W. Then that acceleration is equal to this 450 divided by 1065.24, and finally that acceleration is equal to 0.42 meter per second square. This is the acceleration of the freely falling body, the body which moving downwards. That acceleration is equal to 0.42 meter per second square. We can easily calculate that acceleration by using this D-Albert's principle in rotational motion. D-Albert's principle in linear motion also. Here torque is equal to PR, then that same torque is equal to I into alpha. Then this torque is actually equivalent to force in linear motion. That force is equal to mass into acceleration. Then the analogy of this mass in rotational motion is equal to I. moment of inertia, the analogy of linear acceleration is in rotational motion is angular acceleration. Then torque is equivalent to force. Then instead of F is equal to ma, we can use T is equal to I alpha in rotational motion. This is the concept of torque and radius of gyration, etc. Here once again, this moment of inertia is equal to mass into radius of gyration square. Mass into radius of gyration square, mk square. Here already given that radius of gyration. In some cases they will not give this k square. Then we can use equation for mass moment of inertia of disk, like that ICG Z is equal to mr square by 2 in the case of a circular disk. Okay, thank you all.